Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 29 of the January daily LeetCode challenge, and we again have a very good question in front of us. This is some of the questions that I will say is like really a golden questions of LeetCode. Remember, whenever you get a question, okay, which is among the first 1,000 questions of LeetCode, you can say that it's one of the golden questions of LeetCode because the first 1,000 questions of LeetCode are very very famous. They were very very intuitive and they were like real gold questions, right? Now in this question, we are going to learn about the topic of disjoint set union. Okay, the topic name is disjoint set union. In LeetCode you will also get the name of union find. Okay, so there are like multiple names for the same topic, but yeah, in different platforms they use the different names. So this is the name that mostly like I've seen people using, and obviously in LeetCode you will find this name, right? Now I will explain you the question, don't worry, but along with that, like I've tried my best this time to again show you everything, every aspect of it. So I've taken some sample examples and I've explained how this topic basically works. Okay, how this topic is implemented as such. So I've done a lot of homework, so please be like patient and see everything. I'm sure that by the end of this video you will be having a complete understanding of this particular topic. Okay, disjoint set union. Now in this question, coming to this question, if you see what we are given, it's basically a graph related question, and in this we are going to see how to apply disjoint set union. Remember, there are multiple ways to do this, but again, like it depends. I feel like this topic will be giving the most optimal solution. And like by the way, my solution is beating around 100% of the test cases. I will show you the same. Okay? I can show the proof of the same, right? Now, coming to this question, see what we are given. We are given basically a set of edges. Okay. Now let's see what the question is. In this problem, a tree is an undirected graph that is connected and has no cycles. Okay? So what they're talking about, they're saying that there was a tree. Obviously, like if you see in the diagram itself, there is no directed edge. Directed edge means if the edge has a direction, only in that direction you can travel, right? But in this case, if you see there is no direction, that means if you can, like even if you can travel from 1 to 2, at the same time you can also travel from 2 to 1. Okay, so it's a bi-directional kind of edge. Okay, there's no single direction, it's a bi-directional one, right? Now you are given a graph that started as a tree with n nodes labeled from 1 to n with one additional edge added. So what they're saying is initially you had a you had a tree which had nodes labeled from 1 to n, and then somehow one edge got additionally included in that. Okay. Now what will happen is, see, when you have a tree and you are adding an additional edge, so what will happen? So now it will become a graph which has a cycle. Okay, that is the thing that will happen now. Okay, it had, see, a tree will never have a cycle. That is the difference between a tree and a graph. Okay, it can never have a cycle. But once you add additional edge to two of the existing nodes, what will happen? Now a cycle will be created because of this. It will now be called as a graph, right? The added edge has two different vertices chosen from 1 to n and was not an edge that existed already. So see, with this, they are trying to explain very clearly that the edge that got added is now creating a cycle. Okay, it's now creating a cycle. Okay, with this, the highlight text that I'm showing on the screen, it is now very much sure, it's very much confirmed now that the added edge is now an extra edge, and because of this, a new cycle will be created now, right? The graph is represented as an array of edges of, now they're trying to explain what are these inputs. Okay, they are saying that whatever you're seeing here, that means there is edge between them, right? So see here, 1 and 2 means there is edge between 1 and 2. Similarly, 1 and 3 means there is edge between 1 and 3. Remember, it's a bidirectional edge, so you can travel from 1 to 3 and 3 to 1. Okay, in either direction you can travel. That's what they're trying to tell you in this part. Okay, now return an edge that can be removed so that the resulting graph is a tree of nodes. If there are multiple answers, return the answer that occurs last in input. Remember, because of this, your options are very less now. Okay, because see, like if this part was not there, what I'm highlighting the screen now. Let us say this question, this part of the question was not there. Then you can use any algorithm to find a circle and find a cycle and remove one of the edge. But because this is now included, your options to use as a solution are now very much less. Okay, you have very much less options now to code. Okay, now see this part, the way they're writing the question, see how tricky it is. They are saying you have to just remove one edge and you have to get a tree back. Okay, return an edge that can be removed so that the resulting graph is a tree. Now can you quickly tell me what it means? This means that you will have to remove an edge in such a way that there is no cycle existing now, because see, the only major difference between a tree and a graph is that there is a cycle in, there could be a cycle in graph, but there will never be a cycle in tree. Okay, so if they are trying to tell you that you have to make a graph to a tree, you have to convert a graph to a tree by removing a single edge, that means that you will have to eliminate the cycle that got created because of that extra edge. Okay, and you have to do that in such a way that if there are multiple answers, you have written the last answer that occurs in the input. Okay, now I hope the question is clear to you. You will see in the given graph, you will have to remove one edge in such a way that there is no cycle. Okay, after that. Okay, that is the first point. Second point is that if there are multiple answers, return the answer that occurs in the last input. Okay, Now if you see example number one, the idea here is if you remove any one edge also, it will be a tree now, okay? Because if you, even if you remove a single edge, it will not be having a cycle anymore, okay? So you could remove any edge for that reason, but now that's the reason why they have, given this as the constraint. The idea here is you will always have to check whether the one that we are trying to remove is the last input or not. That is if you see, if there are multiple answers, you will have to guess. That is, you have to return the last input, okay, which could be the possible answer, okay, as simple as that. So in this case, as you can see, 2 comma 3 is the last one, so that is going to be the answer, okay. So answer of 2 comma 3. Now in this again the same thing, any one edge if you remove, you are going to get a tree, okay. But this is the last edge which if you remove, it will be like removing the circle, okay, removing the cycle, okay. Remember, if you remove 1 comma 5, it will not help you with the, see, it will not, you know eliminate the cycle. The cycle will still remain, okay. For that reason 1 comma 4 is the answer, okay. So you can go through the constraints. The number of nodes are going to be till 100, okay. And yep, yeah, none of the edges are repeated, and obviously the graph is connected. So why this is mentioned, can you quickly tell me? Like, if you have been, good in lead code, if you have been doing this consistently, you will now be able to explain what it means. The given graph is connected, can you quickly tell me what it means? So what they're trying to tell you in this is that there are no isolated nodes, okay. Sometimes what happens in a graph question, there are isolated nodes, okay. For example, let us say after 5, let us say there are two more like 6 and 7. So 6 and 7 will not be connected to the main graph, okay. There will be separate sub graph kind of set, right? So in this they are trying to tell you that that will not be the case. Every node will be connected to the main graph, okay, as simple as that. So can you now quickly tell me how to solve this question? See, there are multiple ways to solve it. I will teach you the disjoint set approach, okay. But before that, I want to teach you some of the basics of that. So for that reason, I've created some stuff here, so please let us go through it, okay. Now see this part. I am creating a temp as a set, okay. Temp is now going to have elements of 1 and 2. So if I print temp, it is going to look like this, okay, 1 and 2. It's a separate set, okay, as simple as that. Now, I'm creating a set for A also, okay. In this, I'm having 5 and 6 as the elements, okay. So if you print A now, it is going to show you 5 and 6. Can you quickly tell me if I do this, what will happen now? So I'm taking a new variable B and I'm making it point to A, okay. So remember, this particular, memory is all pointed to by A, okay, currently. Now even B is going to point it to A. Okay? Even B is pointing to this. So if you print B now, even B will be showing you this. Remember, A also is showing the same, B also is showing the same. So can you quickly tell me if I add a element to the memory which B is pointing to, what will happen? I am doing a B dot add, okay, 7. So ideally, what will happen in this, the value of B, you will see additional number 7 is getting added. But if I print A, again in A also you will see the 7 is getting added, okay. So the idea here is, since both A and B are now pointing to the same set, that's why if you add element through A or if you add element through B, both of them will result the same, okay. This is going to be very important stuff when you're going to implement disjoint set union in this example especially, okay. So please pay attention. These things are will be, making sense a lot, okay. The links that I'm creating now will be, very much useful when I'm showing you the code, okay. So please be patient and please learn this basic stuff. Otherwise the solution will be like very difficult for you to understand, okay. Remember, the solution is a small one only, don't worry too much. But again, it will not be very readable if I don't explain all these stuff, okay. As simple as that. Now comes the most important part. See, A and B both are having same values, okay. Now see, the most important part in this case, what we are doing is, in the additional set itself we're adding element, but now there is something new happening. See, now what I'm doing is I'm doing a union, okay. I'm doing a union of A and temp, okay, and the resultant is coming to A. So see, this is the shorthand and this is the long of that, okay. So let me see, this is a commented one, okay. Now this is the long form of that. So what I'm doing, I'm doing a union of A and temp. Remember this symbol that we're seeing, it's basically a bitwise or symbol, but when we're using this in sets, it means a union, okay. I'm doing a union of A and temp. So the result of this, okay, the result of this will also be a set and that is being stored in A. So can you tell me what will be the value of B now? See, after doing this, what is the value of A? See, A is having this much value, 5, 6, 7. Temp is having 1 and 2, okay. Temp is having 1 and 2. So when I do a temp of A and temp, what will happen? The result will have 1, 2, 5, 6, 7, okay. 1, 2, 5, 6, 7. But if you print B, again you are getting same. So why it is happening? See, the answer is very simple. B is pointing to A, okay. So whatever value A is pointing to, that value will be pointed by B also, okay. For that reason, what, see here we did a new assignment for A, okay. A was assigned a new value now, okay. Remember, the previous value is now lost. A was assigned a new value, but still, since B is also pointing to the same place wherever A will point, B will also point to the same place wherever A will point. Because of that, B is also pointing to this same set, A is also pointing to the same set, okay. This is the exact logic that we will now use, okay. Now see this case, I will show example now. Example number 3. Remember, this example will not be given to you directly. I have added this additionally. So I will request that you also add this additionally, so that, because see, the example which they have given, they are like very basic, pretty much. Okay, they are very basic ones. Okay, if you see what is happening here, the same. Okay, what for one is there, then two came. So two, now they're adding extra edge. For three, now they're adding extra edge. Okay, it's same thing. But here, if you see, there's a difference coming. First we had 3 and 4. Okay, now 3 and 4 is now a part of the set. Okay, so see, 3 is also pointing to the same set, 4 is also pointing to the same set. Now remember, the set is stored in memory only once. Okay, this and this are same. Okay, they are stored in the memory only once, but 3 and 4 both are pointing to them. Okay, so don't think like they are stored separately two times. It's not the case. It's stored only one time, and both 3 and 4 are pointing to it. Okay, as simple as that. Now, this was for 3 and 4. Now, 1 and 2 came. Remember, 1 and 2 and 3 and 4, there is no common point between them. Okay. In this case, you see 1 and 2 got added, and then for 2, 2 was there already in the first. Okay. From 2 itself, we are now adding extra edge. Okay. But in this case, if you see, 3 and 4 were there, and now 1 and 2 came. Okay. So, if you try to understand this, 3 and 4 is now a separate isolated component, 1 and 2 will now be a separate isolated component. So, if you see, 3 and 4 are like this, 1 and 2 are like this. That is, 3 and 4 are part of a set now, 1 and 2 are part of a different set now. Okay, so this set and this set is now acting as a disjoint set. Okay, they are not connected, they are not joint. Okay, they are now separate. 3 and 4 is a separate, 1 and 2 is a separate. Okay, 1 is pointing to this, 2 is also pointing to the same, 3 is pointing to this, and 4 is also pointing to this. Okay, so this part and this part are now totally different. Okay, so each node is basically pointing to its set. Okay, but 3 and 4 are pointing to a different set, 1 and 2 are pointing to a different set now. Okay, now see the next edge. The next edge is 2 comma 4. So where is 2? 2 is here. Okay, 2 is a part of different set, 4 is a part of a different set. Okay, so now we are creating an edge between two different sets. Okay, so 2 is part of this set and 4 is part of this set. Both of these set are not joint as of now, but when I create an edge between 2 and 4, now these two sets will become joint now. Okay, so this is where we are doing a union of disjoint sets. Okay, that is why the name of this algorithm is disjoint set union. Okay, so now we are going to do a union of two different sets. Okay, when this edge got introduced, okay, now there will be a link between 4 and 2. Both of them are part of different sets. Okay, now we have to do a union of them. Okay, so after doing the union of how it will look like, see, now even 3 will be connected to 1 and 2 through 4. Okay, 3 and 4 were connected initially. Now there is edge got introduced between 4 and 2. Okay, so now with because of 4, 3 will also be connected to 1 and 2. Okay, that's what is being shown here. See, now 3 is also connected to 1 and 2. So this is the single set now that is existing. Okay, 3 got also connected to 1 and 2. Similarly, 4 got also connected to, okay, 1 and 2. Now 1 got connected to 3 and 4, and similarly 2 also got connected to 3 and 4. Okay, so this was, so now if you see, there is a single set now. Okay, previously there were two different sets. Okay, but now there will be single set, and all the numbers, okay, 1 to 4, all the numbers are pointing to it. Okay, at last we have a new edge now, 3 and 5. Okay, now see what is happening. 3 is already here, but 5 is not there in any of the set. Okay, so 5 is the new number that is getting executed, that is getting introduced. So 5 will simply be added to this. Okay, 5 will simply be added to this. So if you see, after 3 and 5, what happens? 5 got introduced now. Okay, that means all the numbers, that is 3, there's 1 to 4. Now all the numbers are, okay, are connected to 5 now. Okay, as simple as that. Now this 5 is reachable from all the nodes now. Okay, if you see, 3 in the set of 3 also 5 is there, in the set of 4 also 5 is there, in the set of 1 also 5 is there, in the set of 2 also 5 is there. Okay, in the set of 5 also 5 is there. Okay, that means now 5 can be reachable from all the sets. Okay, from all the nodes. Now the last set, if you see 2 and 5, so can you quickly tell me what we are doing here? What we are doing is, 2 is already part of this set, 5 is already part of this set. Now already 2 and 5 were connected. That is, 2 and 5 were indirectly connected. We could reach 5 from 2. Okay, and vice versa. But now they're saying is we have to introduce additional edge. Since 2 and 5 are in the same set, and we are now trying to introduce another edge to them, that means we are now trying to create a circle. Okay, we are now trying to create a cycle. Okay, because of that, we will say that this is the edge which can be removed, and with after removing that, we will be left with a tree which has no edge, which has no cycles. That is the first thing. And now, since we are following the same order in which the inputs are given, so we can claim that this is the last input, which if we removed, it can see, that's what they're writing, right? If there are multiple answers, return the one that occurs in the last. So we can claim that this is the last one which we are trying to remove, in such a way that the remaining edges forms only a tree. Okay, so that is the reason why 2 comma 5 will now be seen as the answer. Okay, we will see, send this as the answer. Okay, so now I will explain how to do this in terms of code. Okay, so this, remember, this is what I have printed here. Okay, so every print that you are seeing here, okay, this part is exactly what is that. Okay, this is the print statement. Okay, yep, this was the print statement, and this is what I'm printing now. I'm going to the edges. Okay, the way they've given in the same order, I will be going now. Okay, for I, j and edges. If see there are multiple cases now, there will be four cases. We'll go through each of them and now see what happens. If I is not in this set, okay, that means I was not introduced previously. I is not existing. Okay, in that there are two cases. Okay, what are the two cases? See, if j is also not present. Okay, where this case can come. See, when for the first time 3 and 4 came, both of them were not part of any set. Okay, for that reason we will have to create a new set in this case, and 3 and 4 should be pointing to that now. Okay, that's what we are going to do. So I is not part of the set of any set. J is also not part of any set. In that case, what we have to do, we have to create a new set. Okay, for this particular key, now I am creating a new set. Okay, this particular key will now be pointing to a new set. In that new set, what are the elements? I and j will be the elements. Okay, both of them will be the elements. And what I will do next, I will make j point to the value to which I is pointing. Okay, please be very clear with what I am saying. I is pointing to a set. Now this set is newly created one. Okay, this set will occupy space. Now after creating that, j will also be made to point to the set to which I is pointing. Okay, as simple as that. Now both j and I will be pointing to the same set. Okay, that means even if I add element through j, or even if I add element through the key I, or through the key j, the element that will be added is in the set. Okay, so it will be reflecting in both I and j. Okay, as simple as that. That's why I showed you this part. See here, when I add element through b and then I print a, so a is also having this change. Okay, because a and b are pointing to the same set, so even if I add it through b or if I add it through a, the changes will be reflected in both a and b. Okay, as simple as that. Right, that's why I'm doing this. Right, next, this was the condition when I was not there in the set. Okay, so we saw both the cases for that. Okay, first case is when j was also not there, and let's come to else case now. Okay, in the else case means j is there but I was not there. Okay, j is there in the set. Okay, in some set already, but I is not there in any set already. Okay, in that case, what I have to do, in the set which, see, j is already existing, right? So the set which j is pointing to, in that set add the element I. Okay, in the set which j is pointing to, add the element I. Then in the key which I see, now I should also point to the set which j is pointing to. Okay? I should also point to the set to which j is pointing to. Okay? As simple as that. Now, the other case, else condition. Else condition means I is there in the set. Okay. Here I was not there, but now in the else condition means I is already part of some set. Okay. Now, if j is not part of a set, what we have to do, same thing what we did here. Okay. Same thing we have to do now. I is part of some set, but j is not part of that set. Okay. So the set which I is part of, in that set add j, and to the set which I is pointing to, make j, the key j also should point to that. Okay, the key j should also point to the set to which key I is pointing to the one which we added j. Okay, as simple as that. Right, now, this part is very crucial. See this part. I is part of I is part of some set, and j is also part of some set. Okay, now is the case where it could happen that we are trying to create an edge between two numbers which are indirectly connected. Okay, there are two cases now. See, I is also part of some set and j is also part of some set. Okay, what we have to do next, we have to just check whether the set which I is pointing to is the same to the set which j is pointing to. Okay, if this is the case, that means I and j are already part of the same set. Okay, that means if we are trying to create a edge between I and j, we are basically trying to create a cycle now. Okay, so if that is the case, that is the set which I is pointing to and the set which j is pointing to, if they are the same, that means we are basically trying to create a cycle. For that reason, we will say that this is the answer and return this as the answer. Okay, simple as that. If this is not the case, what is the else condition? See, this is, that's why I've showed you this. See, 3 and 4. See, when 2 comma 4 h came, 4 is already part of a set, 2 is already part of a set, but the sets are not the same. This set and this set are not the same. Okay, in this case we have to do a union. Okay, that's what we are going to do now. See, in this else condition means both I and j are part of a set, but the sets to which they belong to are different. Okay, I belong to a different set, j belong to a different set. In that case, we have to do a union now. Okay, we'll have to do a union of the disjoint sets. What we have to do, see, this set I'm taking, I'm doing a union of this with this. Okay, but the result will be saved to this. Okay, that is the key I will now be pointing to the result of the union of I and j. Okay, to the result of the set belonging to I and j. Okay, now the result will be there in I. That is, all the values which are pointing to this set will now have the result. Okay, but all the values which are pointing to this set will not have the results. Okay, for that reason, what we have to do, see, that's why I explained to this part. When I do this, okay, a is now having the final result. Okay, that means whichever value we are pointing to a will now have the final result. Okay, this is the final result. Since b was pointing to a will also have b will also have the final result. Okay, now for that reason, whichever values are pointing to I will now have the final result. Okay, but whichever values are pointing to j will not have the final result. Okay, what we have to do then, we have to go to all the values which are there in j and make them point to the set I. Okay, that is to the set to which I is pointing to. Okay, we'll have to go through all the nodes which were there in J, in the set J, and we'll have to make them point to the set to which I is pointing to. Okay, remember all the values, all the nodes which were there in the set I were already pointing to this. Okay, they will already be having the new result, but to all the nodes which are belonging to set J, now they should also start pointing to the set which to which I is pointing to. Okay, as simple as that. Okay, this was the final stuff. If you notice, you can solve this question very easily. Okay, yep, that was all. And yeah, friend, that was all for this video. Like, this was the topic of disjoint set union. Why I will again explain by this name. See, when we are doing this 2 and 4, 2 is part of a different set. Okay, and 4 is part of a different set, so they are like disjoint sets. Okay, they're not related, they are disjoint. Now when we introduce this set, then we introduce this edge, we are basically creating a union of them. Okay, so that is the reason why, if you see, we are now doing a union of them. Okay, both these sets will now be will be part of the union, and the final result will be union of this. Okay, that is why the name came disjoint set union. Okay, as simple as that. So yeah, friend, that was all for this video. And like, the approach that we took is because, see, the idea here is, if two nodes are part of a single set, that means they're indirectly connected. Okay, so if we introduce the edge connecting two nodes which are already part of the same set, then we are basically trying to create a cycle. That was the idea behind this. Okay, so yeah, friend, that was all for this question. And if you see, like, I have completed 99 questions now in a row. I've uploaded 99 videos now in a row, and tomorrow will be the 100 question for me. So if you like my efforts, if you like the content that I'm showing you, if you find quality in this content, please do subscribe to the channel. This really gives us a lot of motivation to continue further. Like, all these things I will try to give in the comment section. Okay, go through them. Please try to go through each and every part. See, it's not about how many questions you solve, it's all about how detail, like how much detail you had when you are solving that question. Okay, so take this part. See, this all part I'm giving it only for you. This is not related to this question, but this is some additional stuff which will be, giving you that mindset of how to test the stuff before implementing a solution. Okay, even I tested it like that, and then I implemented the solution. Okay, so please go through it and try to take the most out of it. And if you have any questions, please do let me know in the comment section. I always go through each and every comment. Okay, and yeah, friend, that was all for this video. If you have any doubts, if you have any questions, if you want to connect with me, or if you have anything to share, please do comment below. I always go through each of the comments. And if you like my efforts, if you like the content that I'm producing, please do subscribe to the channel. This really gives a lot of motivation to continue further. And my aim is that I create quality videos, so that even the one who don't have, like, see, not everyone can purchase courses, right? See, according to me, the coding stuff should be in everyone's reach, the quality content should be in everyone's reach. Okay, my aim is to provide quality content in free for everyone. So that's what I'm working on. I've uploaded 99 videos in total, like, continuously. Remember, this is a continuous one. And like, if you don't see the continuous one, it's like from last 1 year I'm uploading videos. But yeah, the continuous ones are 99 days. So yeah, fun, that was all for today. If you like my efforts, please do subscribe to the channel. This will ensure that the quality content goes to people who cannot afford, like, paid courses. I hope you understand this topic. And yeah, see you tomorrow. Please subscribe. Thanks a lot.